Nice to meet you. I'm Khatar Chuktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain today how to solve question number 2. That is 9701 May June 2023 5-3 variant. Let's get started. So question number 2. Paper chromatography can be used to separate individual amino acids formed when tripeptide are hydrolyzed. One molecule of tripeptide produces 3 amino acid molecule when it's hydrolyzed. A student is asked to identify the amino acid formed from the hydrolysis of 3 different tripeptide A, B, and C using paper chromatography. Figure 2.1 shows the result of the student of chromatography experiment, and here is the ruler on the left hand side, and this is the basic shape of this chromatogram. So A, B, C, basically A has been split into 3 portion, 3 spots, B into 2, C into overall 3, but 2 are quite overlapped. Now what is the basic information over here? The individual amino acid can be identified from their RF values, and here is the formula. RF distance traveled by the amino acid of the spot divided by distance traveled by the solvent front. Now question starts over here. Part A suggests why sample is applied with the help of is applied to the chromatography paper using a thin capillary tube rather than a dropping paper. The basic reason is why we are going to apply the sample with the capillary tube, because in this way the sample is going to be more compact, or the sampling will be more controlled. So in this way sampling is more controlled. It is not going to expand on the paper. It is in a more controlled way, you can say. So that is the basic purpose of using capillary tube. B suggests why it is necessary to spray a developing agent. Developing agent means locating agent over the chromatography paper before the chromatogram can be analyzed. As you have seen that he said that he is going to analyze amino acids. So especially they are invisible. It's an invisible compound. It's not visible basically. So we use locating agents, or we use basically a developing agent to use to visualize them, to make them visible spot, to make them color, to make spot visible. So the basic purpose of locating agent is to make them visible. Part C, table 2.1 shows RF value of some amino acid in the solvent used, figure 2.1. Amino acid RF values are given over here. Use the data in table 2.1 to identify the amino acid in tripeptide A. Here you can see that ruler is given beside this chromatogram. So I'm going to find the different amino acid, and they are having different RF value. For example, in this case, in all cases, I mean, first of all, what is the solvent front? The solvent front is equal to basically, 7. According to the given scale, it's equal to 7. Now, what is distance traveled by this first spot of A, and that is equal to 1. So its RF value is equal to 1/7. What is the distance traveled by the second spot of A? That is this one, I mean overall. And it is almost equal to, the middle of the point is equal to, that is 3.75 if I'm not wrong. 0.75 divided by 7, that is the solvent front. That is the distance traveled by the solvent. Now come towards the third one point, and its distance is basically, its center is equal to almost over here 5.5. So it's 5.5 over 7. These are the RF values of these spots. Same is the case with this one, with the B, and its RF value will be equal to 3.3 almost, or you can say it's equal to 3.2. So roughly 3.2, because I cannot use exact ruler over here. And the next one is the next big spot of B, and its RF value is equal to almost 4.5. So 4.5 over 7, and same is the case, the basic spot of main spot of the C is 2.9 in my opinion. So 2.9 over 7, and these are two ambiguous, I mean that is not clear, these 2 points are not clear point. So this is the way how to find the RF value of any spot. So we can see, I mean, we can diagnose the different amino acid with the help of this RF value tables. Use the table 2.1, identify the amino acid in tripeptide A. So which one is the amino acid in tripeptide A? 1 over 7, 3.7.5 over 7, and 5.5 over 7. So we can find the answer over here, and we can calculate the basic RF values with the help of calculator, then we can find the answer. D part suggests why hydrolyzed sample of B produces only 2 spots, right? Why the B sample is going to have only 2 spots? Basically, 2 amino acids, those is composed up of this tripeptide. It means that this one sample is going to have only, and that is made up of only 2 amino acid. It is made up of only 2 amino acids. That's why it's having only 2. Two of the spot from the hydrolyzed sample of C overlap, as I told you initially. State the reason of the overlapping. The basic reason is they are almost having same solubility in the solvent, number 1. Number 2, they are having same RF values. In my opinion, they are having same solubility in mobile phase, and they are having same RF values. So they are having same RF values. Suggest an improvement to this method that would allow the overlapping spot to be distinguished clearly. The basic major thing is it's a paper chromatography. So in case of paper chromatography, we can use a long paper, a larger paper, a longer paper, we can use a large paper to see the spots clearly, to differentiate them clearly. The second thing is, the basic reason is we can change the solvent. And if we are going to change the solvent, then these are change the mobile phase. I mean, they can be identified properly. So change the solvent or use the large paper. That's all about this question. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with